Okay, so here begins part 5 of the review for chapter 3, and we're going to pick things up on problem number 38, and we'll see how far we go with about 10 minutes or so. So 38 is simply asking me to take the derivative, and I will do this with implicit differentiation because the y is not isolated. So the derivative of y squared is simply going to be 2y. Using the chain rule, 2 comes down y to the first power, but then I have to multiply by the derivative of y. So I get 2y dy dx. And then I have to do a quotient rule on this side. So the derivative of x is 1 times x plus 1 minus the top times the derivative of the bottom, which is 1, over x plus 1, the quantity squared. And so this, I am looking for dy dx, and so I'm going to take one additional step. I really didn't leave myself much room here, so I'm going to cram it in. Let's see, on top I get x minus x is gone. I'm pretty sure I'm left with 1. So I get 1 over x plus 1, the quantity squared, and then I'm dividing by 2y. So it looks like I'll have also a 2y in the bottom here, so I'm just going to put it here at the end. And that would be my answer. Okay, 41 is asking me for, in fact, the second derivative. So the first thing I need is the first derivative. So that's going to give me 3y squared times dy dx plus the derivative of y, which is dy dx, equals derivative of 2 cosine of x becomes negative 2 sine of x. So I need to solve for dy dx, so I get 3y squared plus 1, because I'm factoring out dy dx, and dy dx divided by dy dx is 1, and think of it this way. I need to be able to do the distributive property to get back where I started, so I need to have the 1 there. Negative 2 sine of x, which gives me a first derivative of negative 2 sine of x over 3y squared plus 1. Alright, so there's my first derivative. But now I need the second derivative. So I'm going to take the derivative of this function, and the derivative of the derivative, by definition, is the second derivative, whose notation looks like this. And now I need to take the derivative of the right side, which would be a quotient. So the derivative of the top, derivative of sine is negative cosine, so that's going to cancel out this negative, and I should get 2 cosine of x times the bottom minus the top, that negative and the minus cancel, times the derivative of the bottom, and the derivative of 3y squared plus 1 is simply going to be 6y to the first dy dx. Okay. Oh, there's a quotient rule, so all over the bottom squared. Okay, so technically, or not technically, but I'm pretty much done. With the only exception is that right now my second derivative is written in terms of, at least partially in terms of, my first derivative. So now what I need to simply do is substitute in my first derivative here. And this is going to make a pretty ugly math problem, but let's just write it down. No obvious cleaning up to do here, so let's just do it. 2 cosine of x times 3y squared plus 1 plus 2 sine of x times 6 times y times dy dx. So I take this and bring it down, and sine of x over 3y squared plus 1. Very messy. Apologize for that. All over the bottom. And that should be squared. Alright. That's plenty on that problem. Okay, no way I've got enough room on 45 and 47 here. So, what to do here? 47 asked me and 45 asked me to take the derivative. Actually, it asked me to find the equation of the tangent and the normal line. And so that's going to be a fairly lengthy process. I'm going to skip ahead and I'll come back to those. 57 is the last one I have written down. So let's do 57 and then we'll see where we go from there. Okay, so problem 57, it says determine where the function is differentiable, continuous but not differentiable, and where is it not continuous nor differentiable. I think we need a picture. So we have a piecewise function, and it is defined from -1 to 4, including the endpoints. So -1 to 0, it's linear. I see that both of them have a y-intercept of -3, so both parts. And since the two graphs split at 0, that's good. So that lets me know that at -3, they both meet. As we leave -3, on the right side, this guy's got a slope of 1. So I'm going to have a slope of 1 all the way to 4. So that should put me right there. And then we have a slope of 2 on the other side of 0. And so that's going to be a slope of 2, which is going to look something more like this. And so that is my graph. And so the questions, I think, become quite trivial. Part A, where is it differentiable? And that would be on the interval from -1 to, including -1, to 0, but not including 0 because I have a corner. Slope is 2, slope is 1. They don't match. But, so union, or the word or, 0 to 4, including 4. Again, not including 0. Part B says where is it continuous but not differentiable. So it's continuous everywhere but not differentiable at 0. So it's getting late. It's actually past 2 in the morning right now. Whoop, except it's daylight savings time. It's just switched back to 1 o'clock. So hopefully I'm not reading this wrong. So where is it continuous but not differentiable? So that would be at x equals 0. It's continuous at 0, but it is not differentiable. Part C says where is it not continuous or differentiable, and it's continuous everywhere, so nowhere. And part D says, oh, there is no part D. Alright, never mind, we're done. Okay, so we're at 9.5 minutes on this video already, but let's go ahead and try and squeeze in. I'm going to squeeze in number 47. And to do that, I'm going to erase number 57. Okay. So, it wants the equation of the normal and the tangent line. So once again, all it's asking for part A is it wants you to write the equation of a line. So my answer will ultimately be y equals mx plus b. In order to do that, I need to use the point slope formula. which means I need to have a point and a slope. Well, I already have my point. Now I just need to find my slope. So I simply need to take the derivative and evaluate it at the point. So I will do this with implicit differentiation. And so, well, let's do it over here. The derivative of x squared is 2x plus 2y squared becomes 4y to the first dy dx equals 0. I can plug in for x and y now. I can solve for dy dx, then plug in x and y. It doesn't really matter. Let's just do it now. X is 1, y is 2. So x is 1, this becomes 2 times 1. 4 times 2 becomes 8 dy dx equals 0. Some quick algebra, and I get that dy dx equals, subtract the 2, divide by 8, negative 2/8, negative 1/4. I hope. So now it becomes a very trivial activity, and I get y minus 2, negative 1/4, x minus 1, distribute, negative 1/4 x plus 1/4, and then add the 2. So negative 1/4 x, add the 2, gives me 2 1/4. So there's part A. Part B I'm not going to do, but I'm still going to use the point 1, 2. And now, since I'm doing normal, the definition is perpendicular to the tangent line, so now I'm going to use a slope of 4. And again, I'll let you do that problem. And let's quickly do number 45. And in order to do 45, I'm going to erase what I just did on 47. And so this should be pretty trivial again. I simply want to take the derivative to find my slope, and then I'm going to need to know the point. For this problem, it only gave me x is 3. So the first thing I should probably do is find out what the y value is. So I'm not taking the derivative, I'm just plugging in 3. And I get 3 squared is 9 minus 6. So I get the square root of 3. So that tells me I've got the point 3 comma square root of 3. And then I simply need the slope to go with it. So I'm going to find the derivative, and then it'll be a chain rule. So I get 1/2 x squared minus 2x to the negative 1/2 times the derivative, which would be 2x minus 2. I could clean this up, but I'm just going to plug in the 3 and see where we go from there. So I get 1/2 of, again, 9 minus 6 again, so I get 3 to the negative 1/2 times 6 minus 2 times 4. So let's clean this up. 1/2 of 4 is 2. 3 to the negative 1/2 would be a 3 on the bottom as a square root. So there's your slope. And now it's just a matter of using point slope again. So I get y minus the square root of 3 equals 2 over the square root of 3 times x minus 3. I can distribute, I can move the 3 over, but essentially this is my unsimplified answer. Once again, I'll leave you to do the normal, and the slope for the normal would be simply the negative reciprocal. So for normal it would be slope of negative root 3 over 2. And at 15 minutes, this is a long video, and I apologize. And it's 2 in the morning. Good night.